All right, guys, let's work on the topic for review. There is a classic problem coming up here that is very confusing, and it's all about how well we read the diagram before answering the question. And I like this question because it gives you a chance to really sit there and think about it before answering it, and then you can kind of see where during the EOC or on the test confusion may arise. I keep the question on the test because we covered in class together. We talk about it, and we have to kind of read and determine the intention of the question. So I'm just giving you that warning up front. And when we get to it, we'll cover it in greater detail. But for now, let's start with question number 1. It says, what theorem shows that triangle TNP is congruent to triangle TMQ? So those orders matter. Remember that this says that T and P, so from T to N to P, and then, like we say, swoop back around. So this is our first, our second, and our third. We need to show in that order these are congruent. TMQ, this is my first. This is my second, right? TMQ, and then Q back to T. This is my third. So what I'm going to do is I'm just going to go ahead and write 1, 2, 3 for first, second, third. On my triangle here, I have for number 1, 2 tick marks and 2 tick marks. So we have side congruency and they're corresponding. Number 2, I have nothing on this triangle and I have nothing on this triangle, so that's a good thing. I'm going to leave it blank. And then for my third piece, I have 1 tick mark and 1 tick mark, so that's a side. So right now, just by setting it up this way, I don't need anything else. Well, I guess the way I should put it is I have side, side. So this would have to start with an S. It does not. This would have to start with an S and end with an S. Luckily it does. Here, I don't even have 2 sides to look at, so I'm not going to even consider that. And here, I don't have right triangles. So I already know automatically this is side, angle, side. Now, answering it this way is just the way, this is a test taking strategy. This doesn't mean we actually know congruency. But what we're going to do now is erase all of this. We're going to look at the picture. We're going to actually use our criterion for congruency. And we're going to use some other properties we know. And we're going to actually talk about why this is going to be side, angle, side. And we'll have 2 pieces of evidence to show that we're right. Let me change the colors. So far, we're banking on it being side, angle, side, just by knowing that the order matters and seeing that none of our multiple choice options line up other than this one. So if I come here, excuse me, I have nothing that tells me these 2 are congruent, so I can't pick that. No theorem that we've learned will tell me that those sides are congruent, so I wouldn't have side, side, side. It's not even an option. But what I do know here, let me get the straight line tool because I'm not going to be able to trace this. What I see here is I have 2 lines that cross each other. And this is our vertical angles theorem. Right? Remember, the vertical angles theorem says when 2 lines cross, their opposite sides or their opposite angles are congruent. And just by the vertical angles theorem now, we can see that these 2 angles are congruent. And following the order, we have side, angle, side. And then here we have side, angle, side. So second time, we have evidence that our answer is side, angle, side. Let's get this tool off. All right, number 2, what composition of rigid motions maps ABC to TUV? Now, we have to make sure we're reading that right. Where are we starting and where are we heading to? Start at ABC, and we're stopping at TUV. This means this is the pre-image, and that means this is the image. So before I even look at my options or do anything, I'm just going to verify with myself that we're moving this one to here to map it on. I'm going to look at a couple other things. It looks like A and T. It doesn't look like, we know for a fact. Let's write it here. We need triangle A, B, C to map onto T, U, B. And one of the nice things that we know now is that A and T would have to be the corresponding part. B and U are the corresponding parts. And C and B would have to be the corresponding parts. So that means when I look at this, I need to ask myself, how would I get these to map onto each other? Well, here I have C, and that needs to get to B. So if I translated it, I can see that this is going to cause a problem because AB has a positive slope, whereas T has a negative slope. So that tells me right away I'm going to need some sort of reflection, right? Because I need, or rotation, I need this to go from positive to negative, right? Because it's going to map in this direction. And the orientation of my slope is going to change. Also, you can just see that some sort of flip is going to be required because A needs to map onto T. And if I were to just do a translation, A would land here, and then I would have the triangle here, so that would give me a problem. But I can also see by drawing that, if I did translate this, then I can use this line of reflection, and I have something going for me right there. So let's start looking at our options now that we kind of know what needs to map onto what. Let's see, where's just my plain old eraser? There we go. So I'm going to get rid of all this extra information. I'm going to leave this because I do want to know at a quick glance what needs to map onto what. And then we're going to come back to our drawing. So here we need to, this is telling us to translate 3 to the right and up 2, and then we flip it over the line x equals 0. So that's right here. Now I'm not even going to make this translation happen. I know this is going to move this direction. And if it's over here, I need to flip it the same distance. There's no way. I'm going to be, I'm going to be way over here. These won't map onto each other. So A is automatically out. Let's look at B now. Rotate 90 degrees and then translate. This one's viable, right? Why is it viable? Because our rotation of positive 90 means, and we're in quadrant one, right? We're starting here in quadrant 1. Rotating positive 90 degrees is going to put us into quadrant 2 for sure. And then we're going to have a minor translation. So let's just pick, let's do B and see if we can get it to map on to U. If B mapping onto U works, then we are going to have to test the other 2 points to see if they work. So remember, the rule to translate 90 degrees is that, I believe. So let's pick, or we have picked, so let's find our coordinate for B. This is going to be at 8, 3. So I'm just going to go ahead and put B is at 8, 3 here. And then B prime, once I rotate it, actually this wouldn't be B prime because this is a composition. This is B intermediary. This is just a notation we've kind of made up to let us know that we are doing a composition of rigid motions. And we're not increasing the prime, so we're just going to put that I down there because it's that middle step. We'll increase it to B prime after the translation. So if I do this, I'm going to end up at the point, change the order and negate the y, -3, 8. So here is -3. And way up here, off the chart, is 8. So already I know that my B must go to my U. I'm already way above my U. And I'm just going to take it 1 to the right. I'm not even lined up with it yet. So this is no longer an option either. Let's get through erasing all of this. When we look at our next one. Our next one's going to be a double reflection. So this one should be a little easier to do. So we're going to start, remember, always on the right, and we're going to reflect over y equals 3. Let's get the straight line tool out. Let's do a different color. Y equals 3 is this line right here. We have our reflection identity here with B, so we know that one's not going to move at all. Let's go ahead and do this one. 1, 2, 3. So come up 1, 2, 3. This is going to be C, again, intermediary, because I have a composition of functions happening here. And then I'm 1 below an A, so I'm going to come 1 above. This is going to be A, intermediary. This is our identity, so they stay the same. And now I can see that this triangle is going to just reflect over x equals 1. Bring out the straight line tool. I'm not going to finish this problem. Those of you who really got the concepts of topic 3 down can already see that this new triangle here that I just reflected, it's going to jump over this line. And even if these were to line up here, this one is just shifted 1 unit up too high. So it's not going to work. And what I mean by that is let's just reflect one of them. Let's do C intermediary and let's get C prime out of this. And then it's going to be really evident that this won't work. So this is 1, 2, 3, 4, 5, 6 units away from this line. So I got to go 6 to the left. 1, 2, 3, 4, 5, 6. And this is going to give me C prime. Now C does map to V. Well, there's another problem, right? This should be way down here if this is going to work. Obviously, it's not. So let's hit the eraser and let's look at this one. The reflection across x equals 1, translated 1 to the right and then up 2. Does that one work? So let's find the reflection at x equals 1. X equals 1 is a vertical line. Remember, vertical lines have an undefined slope. So we're going to flip every one of these points over this black line that I just drew. Probably could have picked a more contrasting color. Let's do that. So here's my x equals 1. And we're going to count these down to see if they would flip. So, well, they will flip, but let's see what they flip by. This is 1, 2, 3. So 1, 2, 3 goes here. Here we have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. And here we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to go ahead and erase my counting lines because we don't need those. Oh, I also erased my line of reflection. That's fine. So now we have to label these. Well, B, since this is a reflection and none of these are, we don't have any horizontal lines, it's easy to see that this would be A intermediary, this would be B intermediary, and this would be C intermediary. We've satisfied this part. Now we need this to make these line up to get our correct primes and show that it maps onto the correct thing. If this does not, then we need to go back and re-examine our answers. And I'm not trying to instill doubt in you, but I do want you to know that you can do all of this work and still realize somewhere along the way you may have made an answer. I'm feeling extremely confident about this. But I want you guys to kind of just feel comfortable with the idea that, especially on multiple choice, you may read something incorrectly and then have to go back and double check your work. So let's look at what this translation means. This means go 1 to the right and 2 up. So 1 to the right, 2 up. This would give me B prime. 1 to the right, 2 up gives me C prime. 1 to the right, 2 up gives me A prime. Now, we're not done yet because we haven't verified that the correct corresponding parts have mapped onto each other. Oh, I still want to keep my green dot. All right. So, double check this. This is why I left it up. Is A prime where T is? Yes. Is B prime where U is? Yes. And is C prime where V is? Yes. So this is our correct answer. Sorry I went on that little talk of doubting or maybe the potential of finding out that this one also doesn't work. This is just my automatic mindset during a test. And that is if I get to option D, in my mind that means I may have done something wrong and a moment of panic sets in. All right, so now let's do, I guess the whole point is just don't worry if you start having a little bit of self-doubt. Perfectly normal, perfectly natural. Question number 5 says, what additional, so we're going to have to come up with something here, piece of information is needed to show that triangle GHJ is congruent to triangle MNP by side angle side. So we know that we need, well, I guess I can do this one here. G needs to map onto M and N, and J and P. Or what it's really saying is that GH is our 1, as well as MN is our 1. HJ is our 2. And that means NP is our 2. And then PM is our 3. And JG is our 3. So these are already set up. This is a huge favor. Thank you to the person who made this PDF. We can already see these are in the same order. They have they have a negative rotation, and the corresponding parts are already lined up. So that means that so far we have an angle and a side. And we can see that our first move, MN and GH, are the unknown part. And then we have an angle and a side congruent corresponding piece for each of these. So this is telling us we need to know side angle side. Well, that just means that we have to be able to say that our first step, we needed to show that these are congruent. So basically what we're saying is we need to say that GH is congruent to MN. And if you're watching the video, you're just going to, I just came to the realization I skipped question 3 and 4, so we're doing them a little out of order. Sorry about that. But let's knock this one out. GH to MN would be this side and this side. And that is actually an option choice right here. Right. Another thing, just so you guys know how I think and how I've started to get more comfortable with taking these types of tests. I didn't even look at the answer options. When I did this, I just jumped right in. I was actually so concentrated on this word problem that I didn't even do them in the correct order. But if I have GH and MN, this is side angle side, nothing's better feeling than being able to see this works, and then seeing it be an answer option. Of course, if I had done it this way, HG is congruent to NM, and then I came here, I would not feel any panic because I know GH and HG are the same thing. This just means start at G and walk to H, and however many units that is, it's going to be the same as if I started at H and went back to G. So either one of these could have been a potentially correct answer. That's number 5. Let's go to number 3. All right, number 3 says, what is the measure of angle BAC? So start at B, go to AC. So I want this corner, or this vertex, right here. Well, let me redraw BAC over here. Got B at the top, A on the bottom left, and C. And we know that the measure of angle B is 92. So I'm going to put 92. Now, this isn't the problem I talked about at the very beginning of the video, but you see how nicely and clearly defined that arrow is pointing at that vertex? We have a problem coming up where it's not at all pointing directly where it should be. It's actually coming up when I scroll down to 6 or 7. But anyways, So if I know this is 92 up here, I know the whole triangle has to add up to 180. I know that's a 2. I was going to put 29. I know I'm taking 92 out. And then I know because this side's congruent and this side's congruent, these angles are congruent. So I can just do 180 minus 92, divide whatever is left over by 2, and then I will have my interior angle. And 180 minus 92 divided by 2 gives me, I put 180 minus 92, not 82, divided by 2 gives me 44. So this is 44. Ooh, I don't like that. See, now I'm doing what they did. Let's go in here, and I'm just going to point, I'm going to put 42 down here. 44, actually. And that's going to point to that corner, or that vertex, and that vertex. And I'm just going to leave that information there because I know I have to find the measure of angle CDE next. So let's do that in a completely different color. As I pick a different shade of pink, give me just a second. So CDE means start at C, go to D, then E. So I am looking for this angle right here. Now, some people will say, well, there's not a single piece of information given here, and that's absolutely true. But we do know that this angle up here is 44. And then we can look at this as this line and this line crossing. And this sets up our vertical angles theorem. And we know by the vertical angles theorem that if this is 44, I went right back to that color. What a fool. Let's see. We know if this is 44, then by the vertical angles theorem, this is 44. And we know that if this is congruent to this, then these angles are congruent. So now all I have to do is 180 minus 44 divided by 2. And that'll tell me what angle D and angle E are. 180 minus 44 divided by 2 gives me 68 degrees. So then this angle and this angle are 68 degrees. It's asking for angle D. So my answer there is 68 degrees. Let me box that in so that we can see it's the answer. And that is 3 and 4. There's definitely stuff like this on the test and the EOC. This is one of those classic geometry type problems. Oh, I guess it's down here. Yeah, this is the question I'm talking about. But let's go to number 6. Here's one that a lot of students have a lot of questions about. See if we can fine tune this so that I can get 6 and 7 to show in its entirety. There we go. All right, question number 6. What theorem shows that NTM is congruent to SMT? There's a lot going on here, so let's start by just highlighting the two triangles that we're looking at and then redrawing them. So to go from N to T, right, NT, T to M, and then connect M back to N, we get this triangle right here. So let's draw that. Wish there was a copy paste so that they would at least look congruent. I have N up top, T here, M here. A couple things I want to look at. Here we have NP, PQ, QT. So we have NP plus PQ plus QT. And we have a lot going on here, but we also have very conveniently where this one ends, this one begins. Where this one ends, this one begins. So we can just add all those together and say that they're equal to NT. So that's one nice thing. And I'm just going to do this so that I know kind of where I'm coming from. I'm just going to label this one 6, right? Because 3 plus 2 plus 1 is 6. Now this is just something that I do because I will go back to this problem and I'll look at my scratch work and I'll say, why in the world did you label that 6 when there's obviously not 6 congruency marks necessary here? That's just so that I know I've added all 3 of these. But the segment addition postulate just tells me that NT is congruent. We're going to talk more about other ways to see it. That's just a little thimble. I want to use the word quirk, but it's probably not the best way to describe this. It's a little thimble trick. We'll stick with it. Now let's look at our second triangle. This is S to M. So let's find our S and connect it to M. And already I can see that my NT and my SM have those same congruency marks. So we're going to have something come out of that for sure. Next, I'm going to have M to T. And then wrap it back around, T to S. So let's draw this one here. And let's get some letters on S on top. T down here. M over here. And then I want to look at this right here. I have S to R plus R to Q plus Q to M. And what does that equal? Well, this one ends where this one begins. This one ends where this one begins. Just straight up SM. And I can see here that this is 6 again. So I'm going to put my 6 here. And another trick to help us verify in our minds, let's say that the 1 tick mark length is 1, the 2 tick mark length is 2, the 3 tick mark length is 3. Then the length of SM is 6. And the same here. Then the length of NT is 6. So I actually don't need these Roman numerals anymore. What I kind of have shown, let's see if I can do this without destroying my triangle, is that SM is equal to NT, right? SM equals 6. Sorry, let's make sure we say the length. The length of NT equals 6. Therefore, SM is congruent to NT. So let's go ahead and put our marker there. I'm going to go ahead and do 1, 2, 3, 4 tick marks. 1, 2, 3, 4 tick marks. Now we need to look at some other stuff here. So now we know we have a side congruency. What else can we find out from these two? Well, here's a really nice convenient one. Both of these have MT. Let me change colors since we're talking about a different part of it. I've already used green. Let's go this color. So here I have MT. Here I have MT. Those are automatically congruent to each other because they're the exact same line. So now I can put 5 tick marks here and here. What is that, 5? Yeah. So right now I know I have a potential side something, right? If I can figure out a way to prove this and this are congruent or something else, I could potentially have side angle side. If I can prove that ST and NM are congruent, then I would have side, side, side. I'm starting to get a lot of options here. I just need to figure out which one do I actually want to use. And to do that, I'm going to come back in. I'm going to erase this. And I'm going to go back to my diagram that I was given to see what I can potentially come up with. And I don't think we've used this purple color yet. So we know this is congruent to this. And we know down here is congruent. Do we have anything else that we know? Well, I don't see any way to prove to you guys or myself that these are isosceles triangles. So I'm going to stop looking at just my broken out part. I'm going to come back here and I'm going to look at the major diagram here to see what I can prove. And as I'm looking this over, I am starting to see something that I want to play with. And instead of just jumping in and playing with it, let me show you what I'm looking at. I'm looking at this triangle. And I'm only looking at it because it's an isosceles triangle. And I know something about isosceles triangles that I don't know about, or I can't prove without them being isosceles, and that is if this side length and this side length are equal, then their opposite sides are equal. I mean, their opposite angles. The angles that generated them are congruent as well. So I can go ahead and find angle M. Ooh, can I? No, I need NM MT. So that's not going to quite work yet. Let's see, what else do we know? All right, well, let's keep going down the isosceles hole. Would that work? No, that won't work. So maybe not down the isosceles hole here, but let's do this one. I can also see here that if I look at this triangle, and this triangle, I can make a statement about these pretty easily, right? I can see if I just reflect them over this line, this side and this side are going to be congruent. These two sides are congruent. And by the vertical angles theorem, these two angles. So I know these two are automatically congruent. And that doesn't prove anything for our green and red triangle. But if I know that this and this are congruent, then I have in yellow side angle side congruency. And since this and this are the same, these angles are the same. And now I can say angle M is congruent to angle T by the angle addition postulate, right? Because what's in yellow plus what's in purple is going to be equal to what's in yellow plus what's in purple here. And I now know that angle M and angle T are congruent. And what does that do for me here? Well, if I go in this order, let me get the yellow off because I can barely see that. Have we used the light blue yet? No. If I start here and I go in this direction, there's no angle congruency and there's no side congruency. That does nothing for me. But if I go this direction, I start at a side, I hit this angle, and then I wrap around to this side. So if I can go from 4 tick marks to an angle to this number of tick marks here, we're good to go on this triangle. So here's our side, here's our angle, here's our side. So the answer to this one, after all of that, is side, angle, side. Let me clear this and we can move on to the next one. Which can be proven, select all that apply. So I know with Pearson, this could mean all of them, this can mean one of them, this can mean anything in between one and all of them. This is not the test where select all that apply has 0 right answers. So, probably should have left that diet. Let's put the drawings back up. And let's just erase what we don't actually need for this problem. Oh, I just messed all that up, didn't I? Let's just leave it all up because I'm going to use something every time. All right. So which can be proven? Select all that apply. MPT is congruent to TRM. So M to P to T, that's this guy right here. Let's get the eraser off. So what we're looking at is angle P congruent to angle TRM. Well, I already know that my yellow triangles are congruent, and these are in the same spot, right? If I just reflect this smaller triangle over, they'll map onto each other. So this is a definite yes. Actually, let me get rid of my circles so we're not too cluttered, and let's do that. Line segment PT is congruent to line segment MT. PT, MT. Nope, we have nothing there to say that that's the case because we have shown that these are equal, right? So this is an isosceles. Well, easily put, there's no other triangle here for this one that I have 2/3 highlighted to map onto anything else. And they're not marked congruent. This and this would have to be marked here congruent. So no, we're not going to say that at all. Let me get rid of those lines again. Line segment PM is congruent to RT. PM, RT. Well, we already know by side angle side these are equal. And if I flip them over here at this line, those map onto each other. So those are definitely congruent. So that's the definite answer. And this one says NQM. So start at N, go to Q, then M. Let's hope it's aiming us at this angle right here. And if it is, we already know by the vertical angles theorem it's the case. So SQT. Again, while I'm drawing it, you notice that I said let's hope it's aiming at this. That's just so I can see that what my knowledge matches my multiple choice options. So that's going to be that one as well. So I would go with those three options. PT, MT, definitely not the case. That's just two sides of a triangle. They're not given to us as an isosceles. That triangle is not given to us as an isosceles. So we're good to go on saying that would be the only option we're not choosing here today. Oh, yeah, don't skip all this. Number 8. What is the perimeter of the quadrilateral ABC? So you guys have been doing perimeter for years now. And just remember that the perimeter means the sum of the side lengths. So that just means I need to add up everything on the outside of this triangle. So far we know that we have 11 plus 8. We also need to add whatever BC is and whatever CD is, plus line segment BC plus line segment CD. So let's just go ahead and simplify this to 19 plus BC plus CD. And I have two triangles here. I have one that's an isosceles. That's because this angle and this angle are congruent. And I have one that's an equilateral. So one thing that's nice is I know already that BC is equal to CD because these are equilateral triangles. So I could really just rewrite this as 19 plus 2 times BC because BC can be substituted, or CD can be turned into BC. BC plus BC is 2 times BC. And I just need to figure out what is the length of BC now, plug it in here, and I'm done. Let's break out the eraser tool really quick. So if I look at these two triangles, I have my isosceles here, so I know that if that angle generates an 8, this angle is going to generate an 8. So if this is 8, all three sides of this equilateral are 8. I don't know why my pen got so thick all of a sudden. Let me redraw that for you. So whatever this angle generates, it's going to be the same thing that this angle generates. So that means this side length is 8, this side length is 8, and this side length is 8. So what I really have here is 19 plus 2 times 8, which is 19 plus 16. So my perimeter is 35. That one is definitely on the test. It's definitely on the midterm. It's going to be seen quite a few times. All right, which of these figures appear to be congruent? Sorry, marinated on that one a little bit too long. It would potentially be these two and potentially these two. Now let's figure out which one of them it would actually be. If I want this to map onto here, right, I would need to reflect this so that these are lined up. Now when I do that, this lines up as well, but this side and this point do not line up. So these are not congruent, right? If I flip this one over, this would touch, this would touch, this would potentially touch. It's a little wonky. But you see here, this face would have to flip over to here, and it definitely didn't, as well as this point would have to flip over to here. So I know it's not 2 and 3. Is that an option? Yes. So let's go ahead and cross that one out as a definite no. 1, 3, and 4. That's this one, and this one. Let's just go simple. If I call this 1, this part 2, this part 3, 1, 2, 3 does not work, so that one's out. So it can't be that one either. So none are congruent, or the last two, 1 and 4, are congruent. Let's stick with this method. Well, let's do this. If I rotate this one over to here, boy, you guys know I can't draw, so please bear with me. Already messing up. That would give me the straight line, this piece, this piece, this piece, this piece. Right, so this would come to the right. This would be at the top. This would be my bottom. This would be my left. And then I can see that the lines would connect here. So that looks pretty good, except for this point's facing the wrong way. But it doesn't say can be mapped on in one move, right? It just says congruent. So we can do a composition of rigid motions. Now, if I take this and I flip it along this line, it is going to map perfectly on to the other one. So a lot of this is about drawing shapes, balancing them around in your head, just getting them so that you can show that they do or do not correspond with their congruent parts. Number 10, which of the following cannot be used? I'm not even going to talk about that one because you guys all know that answer. Just give you a hint. Remember, you can't use a bad word forwards or backwards. So it says, number 11, which statement is correct? So we're just going to go through a process of elimination here. All right, m to k to d is the same as going z to u to p. So m to k is this. Actually, let me make this line thicker. So this is m to k. And that's where I get 1 tick mark. Z to u, I get how many tick marks? 3. So that's automatically not it. You see what I'm doing, guys? I'm just following the order, and I'm making sure that we have corresponding congruent parts. Z to u, so if I go from m to k and z to u, those are the corresponding parts, but I can see they're not congruent. I'm going to put a big ol' X here. dm gives me 3 tick marks. That means pu would also have to give me 3 tick marks for this to be correct. That's definitely not happening. Km, so then whatever the next piece is would have to be 1 tick mark. Km to pu is definitely not it. dk to and up both are corresponding, and they both have 2 tick marks, so that is what we're here for. That is our answer. All right, let's move on to number 12. Oh, these classic ones. Refer to the diagram shown so I can hide those directions. Okay, this one's not as bad as they could be. It is helping us out by just giving us specific pieces to look at. So that's nice of them. Let's go with the blue again. So if Wx is congruent to Wz, so let's mark those. That's our hypothesis, right? If something, then what theorem can be shown? Well, I can see that if I flip this over the line YW, that these are in fact the corresponding congruent parts. So then I would have, my first side would be from XW being congruent to WZ. Then I need to look at what else do I know. Well, XP and PZ are congruent. So that's going to give me another side. So I would just need either an angle of congruency, which I don't currently have right now, or I would need to be able to prove the third side in this triangle is congruent. And fortunately, we have the reflexive property right here, and that WP is always congruent to WP. So for this one, we're definitely going side, side, side. Up next, we have if XZ is perpendicular to YW, and so we got a two-part hypothesis. So let's do it one at a time. If XZ is perpendicular to YW, so that means this is a 90-degree angle, and XY is congruent to ZY, sorry. What theorem can be used to show that XYP, so let's highlight that one because we do have two parts here, so they may be trying to set us up for something a little tricky. So go from X to Y, Y to P, and back around again. Can be shown that ZYP, so start at Z and go to Y, and then go from Y to P, and P back to C. So again, we're doing the same thing. We would just reflect it over, and we would have, this one's pretty easy once you do. PY is going to be congruent to PY. And right now, I have to ask myself those three questions. Are these both right triangles? Yes. Why? Well, if this is 90 degrees, by the linear pairs theorem, that's 90 degrees. By the linear pairs theorem, that's 90 degrees. By the linear pairs theorem, that's 90 degrees. So all four of these are, in fact, right triangles. And more importantly, the two that we're looking at are right triangles. The next question, are their hypotenuse congruent? Well, this has two tick marks. This has two tick marks. So yes. And our final question is, do we have a pair of corresponding congruent legs? Well, PY is equal to PY. So this is a third yes. So this guy is by HL without a doubt. So make sure you're drawing these, or at the very least putting your paper over your screen so you can trace them, or at least put the congruency marks on them so you can make sound judgments on these. And our last one, if XW is parallel, well, that's a new one. That's an exaggerated 2YZ. And XWZ, that's this whole thing here. Where was I? XWZ, ZYK. ZYX, that's an X guy. What theorem can be used to show XWZ and ZYK? So this is going to be an interesting one to explain. So how do we go about explaining it? So the answer is kind of looking us right in the face. Well, short of being able to rotate this, let's draw on this. Let's use some of those geometric liberties that we're given. I'm going to go ahead and extend this line out and this line out. So these are parallel. That was given to us. And, I meant to change the color. Let's go purple. Keep the line tool. I'm also going to extend these lines out just to make this a little easier to see. And what we have here is two parallel lines cut by a transversal. This means we can go back to topic 2 and start using some of our knowledge. Right? And basically, what I'm going to do here is look at, because I have an angle here. Oh, I don't want green again. Let's go this dark color. Because I have an angle here and a side here, I really want to be able to do something with this because, again, I have my angle here and my side, XWZ. and zy x. Yeah. I have my side here. Now, to make this work, I need to be able to do something with, I need to show that x is congruent to z. And how do I know it's that one that I need for what I'm given? Because it's the, if I start here and I go in this direction, I run into trouble, right? Because I would have to miss a side, and I'd have to miss an angle to get to this side. Same thing here. So this is starting to leave me with this option, something side. Now, we know it can't be a side. We know it must be an angle because we can't use bad words. So position 1 is an angle and position 3 is the side. There's only one thing I can do to fill this in, and that is to show that these two are congruent, x and z. And to do that, let me clear some of this extra information out. Oops. If I go back to my topic 2 notes, I can see that I have set this up so that this right here and this right here are alternate interior angles and they're congruent. So let me actually already have an angle there. So that's 2. And let me change the color. By the same theorem, alternate interior angles theorem, this one and this one are congruent. Now, by the segment or by the angle addition postulate, I can add my double tick mark to my 3 tick mark and my double tick mark to my 3 tick mark, and I'm going to get the same thing. Again, because this is geometry, we don't have to have concrete stuff, but I can show you that if I were to say my triple tick mark is equal to 3 on both of these, and then my double is equal to 2, I'm going to get the same thing when I add them together, right? That's not quite what I meant. This is 2, this is 3, this is 2, this is 3. So when they're added together, I'm going to get 5, right? They're the same thing as the segment addition postulate that we covered in topic 1. So that's like saying this is 3 degrees, this is 2 degrees, this is 2 degrees, this is 3 degrees. We're going to see those are equal. So I can say by this right here that x and z are congruent. So I'm going to have angle, angle, side for this problem. This class is going to keep building upon itself. There's no escaping that. So if there's something you were weak in since the beginning of the year, make sure you go back to review that. Come to tutoring, ask questions about it. All right, let's look at this one. So this is the one where I said we have to be able to understand the intentions of the person who made this diagram. They are not saying this entire angle is 22 degrees at all. They're saying only this angle is 22 degrees. Now, let's see what we can do with this. It just wants us to solve some stuff. It wants to know what is the measure of angle BFD. Let's get our line tool back out. Let's change colors here. BFD. Go back to B. All right. And it wants to know specifically. Oh, sorry, it's only an angle. It wants to know what is that angle down there. Well, if we look at the triangle BFD, we can see it's an isosceles. And that just means that this angle and this angle are the same, this angle and this angle are the same. But of course, we don't know what FBE is, right? We have no idea what this is. Look at your notes if you're watching this at home. And what does it tell? What do we know if we start here and we hit this side at 90 degrees? It does two things for us. It cuts AC in half, and it cuts the angle, ABC in half, but it also then cuts FBD in half. So if this side is 22 degrees, this side is also 22 degrees. So then we can say that FBD is 44 degrees, And we know that, like we said already, these two are equal. So we can just do 180 minus 44 divided by 22, which I think we've already done. And we think it was, didn't we do that one earlier for an answer? Well, anyways, that makes this 68 degrees and this corner 68 degrees. So if we wanted to simplify this, let's go into a little bit more detail. I'm just going to take this and redraw it because I don't need to worry about the other triangles for this problem. I'm just drawing F, B, D. So let's label them B, F, D. Now, I forgot the key to this problem. This is already given to us that this comes through and meets at 90 degrees. This is a perpendicular bisector. And because this is a perpendicular bisector, if we know this angle is 22 degrees, and let me see what, I'm just going to put all of our givens here. This is 6. Because this is a perpendicular bisector, it cuts this side into equal parts. So we would also know that this is 6 and 6. So the length of FD is 12, but we'd also know that this is 22. So then this together, all of this angle is 44. And then we can see that what was given here. Now you notice I'm changing the congruency marks because for some reason I chose to put 2 here. So I'm just, since I drew this, I can change them. This angle and this angle are congruent. So we just do our 180. Well, we'll just do this again. And that gives me 68 degrees. Separate these triangles makes it so much easier to see how to do it. And we know that this was 6 because we just did that. We know this was 68 because we did that. Now it wants to know what is AC. That's this entire bottom line. Let's highlight it. Well, we've already got half of the problem done without actually having been asked it. But since this comes down and cuts this into equal parts, that means these are equal. And then in the overall triangle, this would be, this part right here would be 16, and this part would be 16. So we have a total of 32. Don't add the 6 back in because we're looking at bigger and bigger parts of the triangle. So let me just show you what I mean. Here, for the whole triangle ABC, this side is 16, where this cuts, then this side must also be 16, and 16 plus 16 is 32. Question number 17. Which triangle is congruent to X, Y, Z? So, oof. All right, let me pause the recording here for a second because I'm going to come back to this one in a minute. All right, guys, so let's do this one. We have RQP. I can label these in order and everything, but I already see something here that I really like about trying to check this one. That has a horizontal line on the grid. So I can just count this length here and say it's 1, 2, 3, 4. And this is PQ, so that's this piece right here. So I need to go to here and see what its corresponding part would be, which is YZ. And then if I can show that YZ is congruent to PQ, that's actually my worst case scenario here because then I do have to check the other two sides and I can't automatically rule out option A. My goal here is to do as little work as possible so I have as much time as possible for the rest of the test. So if I can show that PQ and YZ are not congruent, then I am good to go by ruling out RQP because CTC tells me that all parts of corresponding triangles are congruent. All right. So let's look at what is YZ. And the reason I have YZ is the important piece. It's just like I labeled here. This is X to Y, Y to Z, X to Z. This would be E or R to Q, Q to or P. R to Q, Q to P. I just wrote them backwards. And then P back to R. Since I know that step 2 would have to give me a result of 4, I need to see what would this step 2 give me. And that is going to be YZ. So it's going to be 3 minus 6 squared plus 5 minus 3 squared. And we take the square root of that. This is going to give me negative 3 squared plus 2 squared, which is just, oops, 4 goes on that side. Sorry. 9 plus 4. It's the square root of 13. Square root of 13 does not equal 4, so I can eliminate RQP. So this was actually the best case scenario for us because now we have 3 options left. And like we've already said, this one's most likely not going to be it, just by having placed our paper on our screen, traced it, and done it. So what this is telling me is if I can prove EDF is the correct answer, then by process of elimination, I was able to get rid of LKJ immediately just by inspection. And then RQP, I was able to get rid of because I can show that those two corresponding parts are not congruent, so it can't be that one. Now, if EDF doesn't end up working for us, then we do have to check LKJ because we can't trust our eyes. But like I said, since this is on a scaled grid, we're not really trusting our eyes when we're doing this. We're knowing that these are drawn proportionately and that their lengths should be visually the same since they would be corresponding. And since EDF and XYZ look really good when we trace them out, I'm going to put my money on EDF today. But let's keep moving on and hope that it does show EDF is true. Otherwise, we have to do it all over again, LKJ, and we're going to get tired of doing this over and over again. All right, guys, for EDF, I hate to do this to you. I'm going to call this leave it for an exercise to the reader to prove it. But I have set up everything you need. You need the distance formula, which we have right here. You need the points of XYZ. You need the points of EDF. And you need to figure out each of these line segments' lengths and solve for their lengths and show that they are congruent. I've set them up so that we have them in corresponding order. So if 1 and 1 are equal, those are corresponding congruent. If 2 and 2 are equal, those are corresponding congruent. 3 and 3 equal would mean corresponding congruent. And I would say good luck. Go ahead and pause the video to do them all, check them, and put in the comments what you got before you start the video again. All right, welcome back. On your screen are the answers, and you can see that your final solution would be EDF. For those of you who actually paused the video and solved it, thank you. But I wasn't going to leave you hanging. I wanted to do it. I'm not showing you the distance formula being plugged and chugged all 6 times. That would just drag this video on for an indefinite amount of time, or what would feel like an indefinite amount of time. So we can honestly say EDF is in fact our congruent triangle. All right, number 18. To show that triangle ADB is congruent to CBD by angle side, what must the value of x be? So we're going to go ahead and say that we don't have to do a lot of analysis of the diagram here because they've pretty much told us everything they want. So we're going to assume that they've orientated it properly. But just because I have unlimited time to make this review guide, I want to show you that since it's given all this information, we could probably trust that what our eyes are telling us is that this angle to this angle, 48 to this side, would give us our angle side. And the same here, angle to side would work. Now let's just make sure that when they set this up, they did it in the corresponding order. A to D, D to B, back to A. So we have 1, 2, 3. Well, let's clear this up a little bit. Whoa, not that much. 1, 2, 3. And then C to B is 1. B to D is 2. And then 3. So yeah, they've set it all up. So all we really have to do here is show that angle A is congruent to angle C, and we're good to go. This is going to give me 6x minus 1 is equal to 4x plus 25. And then I just solve for x. This is going to give me 2x equals 26. X would have to be 13. Yeah, I know I skipped a lot of the algebra steps, but we've all passed algebra 1 at this point, so we would know how to add 1 to both sides, subtract 4 from both sides to follow through on all of that. But that would be our answer for that one. All right, guys, question number 19. Which theorem shows triangle ATC is congruent to triangle BTD? This one's pretty easy. Let's look at it really quick. Let me get the pen up. So right here, we know by the reflexive property, vertical angles theorem, that those two are congruent. And because of that, I can see that my 3 questions are a yes. Are they both right triangles? Yes. Are their hypotenuse congruent? Yes. And do they have a pair of corresponding congruent legs? Absolutely. If you want to think about how I know that, if I were to reflect this along line DC, B would come up to where A is. And then if I were to reflect it along that line AT or at the point BT, they would map directly on top of each other. So this is a hypotenuse leg theorem without a doubt. Question 20 is they select all that apply. So be ready for multiple answers to be right or just one to be right, depending on what it has marked up for us. So is triangle ADB congruent to triangle AEB? Let's pull out the line tool just to trace it. So A to D to B and A to E to B. All right. So we have 2 things going for us already. Let's circle those. We know that AE is congruent to AD, so we have a side. We know AB is congruent to AB, so we have another side by the reflexive property. And basically now we just need to know, is anything else congruent? Can we show anything else to be congruent to get ADB is congruent to AEB? And let's look at it really quick. That's not going to help us. Oh, plain as day. This angle generates this and this. And we can say those are congruent. Would that give us something? That would give us side-side angle, which doesn't work. And going this way, that also doesn't work. So that's not a big help. What else can we see here? All right, and then for our angle, so we know we have side here. We really are trying to figure out if these two are congruent to get to this side. And what I want to show you is this. Oh man, how do we do this? This angle or this side and this side are congruent on these triangles. They're both generated by these over here. So we can say this is congruent to this. And then by side angle side, we know A is true. So let me clear all this off. Go ahead and mark A as a definite answer. And while we have it out, if you look at this triangle, you can see that this side is generated, or that angle is generated by that side, and that angle is generated by that side. So they are in fact congruent. All right, how about line segment BD is congruent to BE. So we're trying to figure out if these two are congruent. And to do that, we can say that since we already know this is true, and these are corresponding parts of congruent triangles, this must also be true. So let me say it again, a little bit drawn out this time so you have more time to see what I'm talking about. We've already shown ADB is congruent to AEB, and we can see here that DB and BE are corresponding parts of already known congruent triangles, so they must also be congruent. And then if we look at C, BDC, we're looking for this angle, nope, this whole angle from BDC, and BEC, so BEC. We want to say, are those congruent or not? Well, right now we know ADB and AEB are congruent, so we know these sides are also congruent. And they're already given this, so we have side, angle, side congruency, so we're good there. I don't know why I'm circling it and checking it. I guess just because I feel really good about them. And then the final question is AB, line segment AB congruent to BE? Well, let's look at that. AB and BE, are they congruent? Well, this is not an isosceles triangle. It's not given to us that it's an isosceles triangle. With some of our other information, we know stuff like this is congruent now, but not, so we're not seeing any congruency reason here. Later on, we'll learn about the centroid and a couple other things, and we might be able to make more of a statement on it, but even then, we can't really say much about this, so this one's not going to be true. All right, that is topic 4 review. I'll have it uploaded shortly.